Welcome to the third session on analog communication practicals. Today we will see the demonstration of next two practicals, that is FM modem and analog sampling and reconstruction. Let us start with the first practical, that is FM modem. This is the FM modem experimental board. The upper section provides the FM modulation operation and the lower section provides the FM demodulation operation. In this, we have a signal generator section which provides me modulating signal. Also, we have IC 8038, which acts as a VCO, that is voltage controlled oscillator, which generates oscillations depending upon the applied control voltage or DC bias. Also, we have IC 565, that is PLL, which is used for demodulating the frequency modulated signal. Let us see the demonstration of FM modem stepwise. So initially you have to set the message signal to 1 volt peak to peak and 1 kilohertz frequency. You can connect the DMM at the DC bias point. You can connect DSO at the output of buffer. Now you can adjust the frequency at the spot so as to get 50 kilohertz frequency on the DSO. We can measure the DC bias voltage at which I am getting 50 kilohertz signal on the DSO. I can assume this DC bias voltage as X volt. Vary the frequency at the spot so as to get X plus 0.5 volt on the DMM. I can note down the frequency at which I am getting X plus 0.5 volt as F1. Vary the frequency at the spot so as to get X minus 0.5 volt on the DMM, and I can note down the frequency at which I am getting X minus 0.5 volt as F2. I can adjust the frequency at the spot so as to get back the 50 kilohertz frequency, that is the center frequency of 8038, and I can disconnect the DMM. As we have set message signal as 1 kilohertz and 1 volt peak to peak, we have found out the frequencies F1 and F2 at X plus 0.5 volt and X minus 0.5 volt. If we will set the message signal amplitude to 2 volt peak to peak, then we have to find out the frequencies F1 and F2 at X plus 1 volt and X minus 1 volt. After that, we can calculate the frequency deviation and corresponding value of modulation index, that is beta. We can calculate the frequency deviation by the formula as F2 minus F1 upon 2, and we can calculate the modulation index beta by the formula delta F upon Fm, that is frequency deviation upon modulating signal frequency. Now we can apply the message signal to the input of 8038, and we can observe the FM signal and its frequency spectrum on the DSO. Now we can change the modulating signal frequency so as to have another value of modulation index, that is beta, and again I can observe the FM signal and its frequency spectrum on the DSO for the new value of modulation index beta. I can repeat the step 14 and 15 for at least 2 more values of beta. Now we'll go towards the demodulation of frequency modulated signal, so we can connect the DSO at the signified point. I can vary the frequency at the spot so as to have 50 kilohertz varying frequency of PLL. I can disconnect the DSO from that point. I can apply modulated signal to the input of PLL. I can apply output of PLL to the input of filter, and at the output of filter, I can observe the recovered message signal. So this is what is the demonstration of frequency modulation and demodulation. The probable questions are mainly on FM. So a few questions are like, what is FM, expression for FM, frequency deviation, modulation index for FM, types of FM, VCO, PLL, different methods of FM generation and detection, basis function, etc. etc. So this is what is the first practical FM modem. Now let us start with the second practical, that is analog sampling and reconstruction. This is the analog sampling and reconstruction experimental board. Audio generator section will generate the modulating signal, whereas getting pulse generator section will generate the train of pulses. Modulator block will do the modulation, that is, it gives out the natural sample signal, sample and hold signal, and flat top sample signal. And the demodulator block will demodulate the modulated signal, that is, it generates or recovers the modulating signal from the sample signal. Now let us see the demonstration stepwise. So first of all, connect DSO to the message signal, adjust the message signal to 1 to 3 kilohertz frequency and probably the voltage greater than 5 volt. Then you can set the getting pulse signal to 16 kilohertz frequency. We can adjust its duty cycle as 50% duty cycle. Now here we can connect the message signal to the channel 1 of DSO. Once we'll connect the message signal to the channel 1 of DSO, then we can apply the message signal to the input of modulator block. We can apply the getting pulse signal to the second input of modulator block. Now we can connect the output of modulator to the second channel of DSO. Then we can observe natural sample signal. Then we can observe and draw the spectrum of natural sample signal. Also, you can observe the flat top sample signal and sampled and hold signal. Now, let us connect the natural sample signal to the input of demodulator section. Once I will connect the natural sample signal to the input of demodulator section, at the output of demodulator section, I can observe the recovered message signal. So this what is the simple demonstration of analog sampling and reconstruction experimental board. So the probable questions on sampling are: what is sampling theorem, natural sampling, fat top sampling, sample and hold, PWM, PPM, generation and detection of PAM, PWM, PPM techniques. So that is what is the today's second practical, that is analog sampling and reconstruction. Thank you.